Well, hey everybody. Today we're going to solve some equations with the logarithms, with the logarithm properties, with the calculator, pretty much everything that we've done in these problems. Everything we've done you'll see in these problems. The first kind or style of problem is when the bases match. And so this is log base 3. This is also log base 3. So they match, and when the bases match, you know you can get rid of them. And so this is just going to be 3x equals 36, and so x equals 12. Now, when solving these problems, you do have to be mindful of the fact that you can't take the log of something negative, and so you do have to check your answers. If we plug this back into here, we're not taking the log of anything negative. We're taking the log of 36, which of course is good. In problem like number 2, don't just be quick to get rid of this. Think about your logarithm rules. Subtracting is dividing. So let's write this as a single logarithm. Log base 5 of 2x over 10 is equal to log base 5 of 3. If you would have left that a subtraction problem, it would have been incorrect because we're not subtracting. Now the bases can be eliminated, and we just have 2x over 10 equals 3 over 1. Cross multiply, and we end up with, oops, that's a 30. We end up with x equals 15. And again, when you take a back look, when you think about putting a 15 into there, we are not taking the log of anything negative, so it works. Now you can't put the 15 here or here because there's no letters. Now for number 3, it's not written as a log, so we have to do that. The base is 8, so we're going to do log base 8 of both sides. And on the other side, this looks like log base 8 of 50. Now don't turn around and cross those off. Yes, the bases match, but we did that on purpose. Right? So the right-hand side, we're not going to cross that off. But the log base 8 of 8, those get eliminated. So that brings this power down out of the power and just makes this 2x plus 1 equals log base 8 of 50. Now, normally what we would say with logarithms is use the calculator once. Like, don't put log base 8 of 50 in there and then do all the steps. So we're going to finish this problem, and then we'll put it into the calculator. So we have 2x equals the log base 8 of 50 minus 1. That's not the log base 8 of 49. That is some weird number minus 1. And then we'll divide by 2. Then this is everything you would put in the calculator. And so check to make sure you're using the calculator correctly. You should get 0.441. Now for the next style, we're not going to explain each step. We're just going to solve this. The bases don't match, right? We have 10 as a base. Now over here, the 270, that really isn't a base. That's just 270. There's no power there. So we're going to use log base 10. Log base 10 is the common log. So I'm not going to write base 10. That's extra. So we have log of 10 to the x minus 1 equals the log of 270. This is just the regular log button on your calculator. Now, of course, just like we saw before, that's gone. So x minus 1 is equal to the log of 270. And then clearly all we have to do is add 1. When you put this into the calculator, your calculator does this. It automatically, you push log, it gives you that. You have to close it, and then you add the 1. So make sure you pay attention to the parentheses. Well, here we get 3.431. You don't close the parentheses, you get a different answer, which is basically the wrong answer. Don't blame your calculator for that. That's your fault. Before we can do anything with this guy, we got to isolate him, so we're going to add the 3. So we get 5 of e to the x plus 1 is equal to 15. Now we can still get this e by itself, dividing both sides by 5. So e to the x plus 1 is equal to 3. Now, how do you get rid of base e? We get to take the natural log of both sides. So we're going to put the natural log on both sides. I just rewrote it because I didn't know how to squeeze it in there. It has to be in front. The natural log of e, that's a 1. They are inverses of each other. That is gone. So now we're left with x plus 1 equals the natural log of 3. And we get x equals the natural log of 3 minus 1. But again, the natural log is the same. Make sure you close the parentheses and then hit minus 1. value here is 0.099. Check your calculator. Pause this, put it in there, see if you did it right. Number 6 looks super tricky. We got to remember e to the x times e to the x. You would just add the powers. So in order to split this up, right, split up e to the 2x, that's going to be e to the x times e to the x. It's just like looking at x squared. It's a factoring question. So now we want to multiply to get 5. Well, that can only be 5 times 1. And we add these up, we want a negative 4. Now we're going to set each factor equal to 0. So e to the x equals 5. E to the x equals negative 1. No, it doesn't. It can't equal a negative number, so that's tossed out. How do you get rid of e to the x? You take the natural log of both sides. That's gone, so we have left with x equals the natural log of 5. Put that in the calculator. We get 1.609. These are going to be going the other way. Now you can see the word log or natural log is in the problem. On the front, it was the exponents that were in the problem. So we were going to have to use exponents to get rid of the logs. We use logs to get rid of the exponents. So here we first of all we have to get this natural log by itself. So we have the natural log of 3x equals 6. Well, this is swooping. That's how you get rid of the log or the natural log. There's no base, but it's base e. So e to the 6th equals 3x. And then we're going to divide by 3. So when you push E, you go second, and then on your screen you'll see E. E automatically pops up like this. Automatically. You push E and it just does that. So you don't have to push the power key or anything. Just put in the 6, close the parentheses, divide that whole thing by 3. We get x equals 134.476. Over here, we're going to divide by 3. So we have the log. Don't do anything with this. Don't distribute that. Don't do anything strange to it. It just stays like that. 13/3. Now we're going to swoop. No base, base 10. So 10 to the 13/3 power is equal to x minus 4. So 10 to the 13/3 power plus 4 is x. Put all that in the calculator. It's a big number. 21,548.347. Everyone's favorite square root. Switch that to the 1/2 power. And now, of course, we can bring this down out in front. So we have 1/2 natural log of x plus 2 is equal to 7. Well, we can't have this 1/2 here. So you can either divide both sides by 1/2 or multiply both sides by the reciprocal. I'm going to multiply both sides by the reciprocal. I'm not squaring, I'm multiplying. So this is gone. So the natural log of x plus 2 is equal to 14. Now you swoop, because you have the natural log on one side, no other extra stuff. So e to the 14th is equal to x plus 2. So e to the 14th minus 2. This is a big number. This is the million. 1,202,602.284. Fills up the screen. Now you have to check your solutions when the word log is in the problem. If you don't have the word log in the original problem or natural log, then there's nothing to check. Because a power can be negative, a power can be a fraction, a power can be 0. But logarithm is very, very picky. So let's put this back together. This side is a division problem. So we have the log of x plus 5 is equal to the log of x minus 1 on top of x plus 1. Now they have the same log base 10, so that can be gone. And we're going to cross multiply. I'll rewrite it here. X plus 5 over 1 is equal to x minus 1 over x plus 1. So we cross multiply. X minus 1 is equal to x plus 5 times x plus 1. Now you know the pattern, right? You add to get to the middle, multiply to get to the end. In order to solve this, you have to set it equal to 0. I don't know why I left that x minus 1 in parentheses. So we're going to have x squared. We're going to subtract the x, and we're going to add the 1. So we get plus 2 plus 3. So our answers are x equals -2, x equals -3. We'll put that back into the problem. If at anywhere you get a negative, I'm thinking we should put it right here just to make this faster. If you put a -2 in there, you get a negative number. If you put a -3 in there, you get a negative number. Just has to occur in one spot. Doesn't have to occur in all of them, just one. So it just takes one. So don't just check one, check them all. This is no solution. I checked one because I checked the one that was going to force me to probably get a negative. The others would be fine. Now for this one, we of course have to divide both sides by 3. So we have 5 to the x is equal to 7/3. I'm going to write this kind of different, times 2 to the x. Now I'm going to divide by 2 to the x. So check this out. These have the same power. So if I had 3 squared over 4 squared, that would be the same thing as 3/4 squared. Well, I'd like to write the power just once, because power everywhere is difficult. So I'm going to write this as 5 over 2 to the x power. Over here, I just have 7/3. Now we do the logarithm of both sides. That's how we get rid of a power. Log base 5/2 of 5/2 to the x equals log base 5/2 of 7/3. Now, if you have that key on your calculator, this is very easy to put in the calculator. We have x equals 0.925. Now, story problem going backwards. Margaret invested $2,500 in an account that earns continuously compounded interest. After 5 years, she had $3,130.81. Solve an equation to find the annual interest rate. Okay, so we have PERT, right? So we know the original was $2,500, the principal. E, the rate we don't know. The time is 5 years, and we know the answer is 3130.81. Okay, let's divide by the 2,500. I'm going to leave it like that. I don't like to write decimals over and over again. I don't want to round in the middle of the problem. So we have e to the 5r is equal to this fraction, 3130.81 divided by 2,500. You round right here, you just messed up the problem, so don't do it. Now, in order to get rid of base e, we take the natural log of both sides. I'm going to just squeeze this in here. Now this is gone. So we have 5r is equal to the natural log of this fraction, 3130.81 over 2,500. I just put it in parentheses for clarity that we are taking the natural log of the whole thing. Then we have to divide by 5. So then you have to take that entire fraction and divide by 5. This is what goes in the calculator. Now when you put it in there, you get 0.045. But the question says to round to the nearest tenth of a percent. So be sure to move that over. So the answer is 4.5%. Fun times. Do the assignment and make sure you come to class with some questions if you have any.